All right, we are now on to some very interesting topics toward the end of this unit. This is section 1.5. I can solve and graph compound inequalities. So the word we're going to put here is compound. Compound. Now the word compound has lots of different meanings. To give you some indication of what we're talking about here, it says water is a chemical compound. What does the word compound mean? So you might remember that water is H2O. It's two hydrogen molecules with one oxygen molecule. So when we say we've got a compound in this context, what we've got is we've got a mixture. We've put some things together. So we've mixed some things together. All right. So we've kind of added things together or something like that. Now we're really good at solving inequalities just one at a time. We know how to do that. We're really good at solving those, graphing those, and then writing the answers and stuff like that. But we're going to solve some things that are more complicated. They've got more than one inequality at a time, which is why we call them a compound inequality. We're going to mix several inequalities together, so we call them a compound inequality. So the words that we use to join inequalities together so that we can mix them together, there's two of them. One of them is the word and the other one is the word or. Now when we're dealing with inequalities, the words and or, their meanings are very different and we need to be very clear about what they mean. So the word and, since we're only going to work with two inequalities at a time, the word and means both. The word and means both. And the word or means one or the other or both. So and means both, so both inequalities are true, and the word or means one or the other, or both of them could be true. So we're going to take a look here. I've got a couple of examples, and I'm going to slide this down here. And I've got my examples. I've got two of these. This is our first example of a compound inequality. I've got two inequalities here. One of them is in red and one of them is in blue. And in order to keep them straight, I am going to graph those and do the work separately in those colors for each one of those. So it says solve, graph, and determine what range of answers, what the range of answers would be using what and means. So remember, and means both. So we want both of these to be true at the same time. So I'm going to grab my red marker right here and I'm going to go ahead and solve this. So we're just going to divide by 3. And remember, the only time we do anything different with an inequality versus an equation is if we multiply or divide by a negative, which I haven't done here. So I'm going to leave the inequality in the same direction. So I've solved that one, okay? And then I'm going to write the word and here. And here's the other one, so let me go ahead and solve that one. So I'm going to move the 2 to the other side by subtracting 2, and I get this. I get x is less than, subtracting doesn't change the direction, so we get that right there. So here's the compound inequality. I've simplified it. Technically, I've solved it, but it's really hard to understand what the answer means here because we want both of these true at the same time. So here's what I'm going to do. I'm going to graph the red one. So the most important number on the number line here is -4. So I'm going to put a 0 right here. I'm going to put -4 about right there. I'm going to circle it, and we do need to fill that in. So I'm going to go ahead and fill that in. And then the answers, the x's are greater than or equal to -4. So that means we're going to shade this direction right here. So I'm going to go ahead and do that, and I'm going to just do some light shading right here in red. So we've done this before, no problem graphing the answer to that one particular inequality. Now we're going to graph the other one. The other one is in blue, and it says x is less than 2. So according to this scale, it looks like 2 would be about right there. I don't fill in that endpoint because it's not equal to 2. And the answers, the x's are on the small side, so the answers are less than 2. So I'm going to shade this direction right here. So we're going to draw a line right there and a line right there. And I like shading the opposite diagonal when I have to do one of these. So here's the deal. We want to think about what the word and means. And means both. We want both of these to be true at the same time. So let's take the red one. Anything that's shaded in red would make the red inequality true. Anything that's shaded in blue would make the blue inequality true. Well, if we want them both to be true, we've got to find somewhere that has both types of shading. So both types of shading would occur basically from here. Whoops, I forgot to put the 2. From -4 all the way up to 2. So right in here. So we'd start about right here. And notice that this is shaded in with red and blue. So it'd be about right there. And then everything is blue and red shading up until here. but that circle is open, so the only type of shading that fills that in is the red shading as we go past that with that red shading there. So from here to here is basically the right answer. Now you'll notice that this is kind of messy when we've got one of these with an and in it. So there are two number lines on this problem because it is messy, and you might need to have one number line where you just kind of figure out, okay, I can see what the answer is. The answer is this stuff right in here, and then another number line to put your final answer on. So here's what I'm going to do. I'm going to put 0 about right there. I'm going to put 2 right here. I'm going to circle that. I'm going to put -4 right here. I'm going to circle that. And remember, the 4 was filled in. It was covered with both types of shading. The 2 is open, so I'm going to leave that open, and then I'm just going to shade in between the two of those. So we're going to shade like that right there, and then I'll just do a little bit of diagonal shading, and there's the answer. Now, I do like this type of shading better than just kind of this drawing a line and putting an arrow on it and stuff like that, because I think it makes it a little bit more what we're looking for here. We're looking for the overlap. We're looking for both of them to be true. We're looking for both types of shading. Okay, so let's come down here and let's talk a little bit more about compound inequalities that have the word and in them, that are connected by the word and. Since the solution is where the graphs intersect, in other words, where there's both types of shading, this type of conjunction, the word and, remember that's a conjunction, is called an intersection. Intersection, it's where they overlap, okay? The symbol for an intersection, so mathematicians always like little shortcuts rather than writing this big long word intersection. We've got this kind of little upside down U. That's an intersection, okay? So this right here is called an intersection. It's the intersection of the blue shading and the red shading, and the final answer looks like that. So technically, this is the answer if we wrote it as an inequality right here. And this is the answer if we were to graph it. So we've got the answer as an inequality, and we've got the answer as a graph. So I'm going to slide down here, and we're going to take a look at one with an or in it. So I've got a couple different ones. Again, I'm going to go back to the different colors. I'm going to solve this. So I'm going to divide by -5, and dividing by a negative does change the direction. So this is going to be a less than or equal to -4. So I'm going to go over here and do the other one. So I'm going to move the -3 over by subtracting 3. Remember, subtracting 3 doesn't change the direction of the inequality. So I've got a 5, stays the same direction. So that's a less than. So if I read it backwards, this is x is greater than 5. And I'm going to put the word or between here. So the word that connects the two of these is or. Now remember what or means. Or means one or the other or both. One or the other or both. So let's go ahead and graph this and keep that conjunction, the word or, in mind to figure out what the answer is here. So we've got -4 and 5. So I'm going to put 0 about right here. -4 we'll put about right there. I'm going to circle it. It can be equal to that, so I'm going to go ahead and fill it in. And then the answers for this one are less than or equal to -4. So I'm going to shade this direction right here. So we'll go ahead and do that. And then the other one, I'll go to the blue. This one is 5, so I'm going to put 5 up here. I don't fill it in because it's not equal to it. And then I'm going to read from the variable x is greater than, the answers are greater than 5. So that would be on the big side of 5, so that would be this right here. Now, the word or means one or the other or both. So what that means is any type of shading is okay. If it's shaded by red, it's going to be part of the answer. If it's shaded by blue, it's going to be part of the answer. If there happens to be somewhere that overlaps like we had on this one, any type of shading is okay. Now, I do have a separate number line over here, and I'm going to go ahead and use that on this one. This is not very messy. This is the answer right here. So the answer as far as inequalities go are right here. And then the answer as far as graphing are right here, but I am going to go over here and I'm just going to do a 0 really quick, a -4 really quick. I'm going to fill this in and then I'm going to shade to the left just to kind of match the way we did the one up here. So here's a 5. We're going to leave that open and we're going to shade there. So there's the inequality form of the answer and there's the graph part of the answer. So the answers would be anything less than -4 or anything bigger than 5. 5 is not included in the answers, but -4 is included in the answers. Okay, so I'm going to slide down here and let's talk just a little bit more about this conjunction, the word or. So since the final answer is the interval with any type of shading, This type of conjunction is called a union. When you union things, you literally just put them together. Okay, so we're going to take this answer and we're going to put them together. So anything like that is okay. And so a union is kind of a funny looking U shape. It looks like a capital U there. So in summary, here's what we've got. And means both. The symbol for that is an intersection, so it's this upside down kind of U shape. And or means one or the other or both. And the symbol for a union is this right here. It looks like a U. U for union, and then flip that over, that's an intersection. They're kind of opposites of each other if you want to think of it that way. All right, so let's slide down here and let's take a look at a couple of these. We're at the bottom of this first page here. And it says, draw the symbol for the and or the or, graph the compound inequality, clearly shade your final answer. So I'm going to do this right here. I'm just going to stick with the red here. The word or is one or the other or both. That's going to be a union. We're just going to throw everything together. So I'm going to use a union on this one right here. Now notice that this is already solved, so I don't have anything to solve. So let's go ahead and graph here. This is x is less than or equal to 1. So I'm going to put a 0 right here. I'm going to put a -1 right here. Circle that. That is filled in. I think just by coincidence, all these on the left side have turned out to be filled in. And then we're going to shade less than. So we're going to shade over in this direction right here. Okay, and then the other one is a 4. So we're going to circle the 4. We're not going to fill it in, and the answers are greater than that, so it goes like this. Okay, so that right there is the answer. So we use the right symbol. That's the union symbol. So the answer is you union this with that. So you basically put them all together. So anything that's shaded is going to be part of the answer. Now over here, let's see what we've got on this one. I'm going to go ahead and solve this one. So I'm going to subtract 5. So we get 3. Greater than x, or read backwards, x is less than 3. And that's going to be an intersection. So we want to know where these intersect, where these overlap. And then this one right here is x is greater than or equal to -2. So again, this one was already solved. That one, this one was already solved. The first one we needed to go ahead and solve that. So I'm going to put a 0 right here. I'm going to put a 3 right here. So I'm going to put a 3 right there. We're going to be shading less than that. So anything on this side is going to be shaded. We're going to be shading all the way over here. And then -2, I'm going to put -2 right here. I'm going to circle that. We are going to fill that in. Gosh, I should have fixed these so they weren't always on that side. It doesn't always work out that way. And then x is greater than or equal to -2. So greater than -2 would be going this way. So if I were to shade using colors, let's say the blue one would go this way, and the red one would go this way. And this is where they get to be a little bit messy. We want to know where they overlap, where the intersection is. So that would just be from here to here. So here's what I would do. I'm going to erase those, and then I'm going to grab a black one, and I'm going to say, look, it's from here all the way up to here, not including those. And then I just make sure that it's very clear when people are looking at this, that they know, hey, he knows what he's doing. We know where this answer is. It would be right there. Okay. All right. So that's how you do those. And we're going to come down here and we're going to take a look at this right here. I want you to notice that we've got this inequality, this compound inequality. This looks really weird. It's kind of like a three-sided inequality. There are some inequalities that are nicer than others, and this is one that's really nice. And what I'd like you to notice is we really do have two inequalities here. This one, so if I were to cover up this part right here, I know you can still kind of see that. This says x is greater than -6. And the other one, if I were to cover up this guy right here, says x is less than or equal to 0. So if you were to see something like that, it does not have a word or a symbol in it. It doesn't have a union or an intersection. It doesn't have the word and or. So it does not have a word or a symbol in it. And the only compound inequality that can be written without a word or a symbol is this guy right here. It's an intersection. And if it's an intersection, it's like this guy right here, then the word that connects those has to be an and. So the awesome part about this is we can actually have a compound inequality without using the symbol or the word and, but and is the only one that can be written like that. If it's got an or, you have to write the or you have to use the union symbol. So let's take a look at this right here. It says, we're on the second page, so it says solve and graph the compound inequality, and clearly shade your final answer. So on this one right here, these are kind of cool. It's kind of like a three-sided inequality. So what I'm going to do is I'm going to add 3 here, and I'm going to add 3 here, and I'm going to add 3 here. So those are going to cancel each other out to be a 0. We're adding, so that doesn't change the direction of any of these inequalities. This is an 8, and this is a 2, and here's the answer. So let me read this for you so you can understand where we're coming from, that this is an and this is an intersection. So what we mean is we want the x's, we want the answers that are greater than 2, and at the same time they need to be less than or equal to 8. So let me say that again. The answers right here have to be bigger than 2, and they have to be less than or equal to 8. So let's graph what that looks like. So 0 is going to be here, 2 is going to be here, 8 is going to be here. So I'm going to put a circle over each one of those because those are the 2 most important numbers on this particular graph. And this one is filled in. So finally we got one where the right one is filled in, and the other one is not because it can't actually be equal to it. And we want the numbers to be bigger than 2, and at the same time they've got to be less than 8. So what we're talking about is this little bit right in here, so we're going to go ahead and shade that in. So there is the answer for that compound inequality. They're bigger than 2 and at the same time less than 8. So if you've got just that one little interval, that one little chunk inside, that's the answer. That's the intersection of the 2 of those. Okay, so the word here is and, so that's going to be an intersection, so we want to know where these cross each other. So let's go ahead and solve this. So I'm going to move the 5 by subtracting. So that's a -9 less than or equal to 3n. We're going to divide by 3. So here's what I've got. I've got a -3. And I didn't divide by a negative, so we were good there. And then over here, I'm going to do this. Let's see. So we're going to add 3. So 2n less than or equal to 10. We're going to divide by 2. So here's what we get. N is less than or equal to 5. Now, this is an intersection. It's an and. We want both of these to be true at the same time. So let's take a good look at this. So I'm going to put 0 about right here, -3 here, and I'm going to put open circle on that one, and I do have to fill it in. And then we're going to do the same thing over here. So 5 is going to be over here. I'm going to put a circle. It can equal that, so we're going to fill it in. And then let's think about this for just a second. We want to know where these overlap. So hopefully they do overlap. Sometimes they do, sometimes they don't. Most of the time they do. So we want to know, let's see, so we want the answers to be bigger than or equal to -3. So we're going to be shading that direction on this one. And then this one is n is less than or equal to 5, so we're going to be shading that direction on that one. So if you want to bear with me here, this shading would go all the way over here. It would go way out to the right end, and this type of shading would go all the way over here, way out to the left end. So this would only have red shading, this would only have blue shading, but in between here it would have both types of shading, and you'll notice because each one of these are filled in, they would be double shaded, shaded by the red as it goes by and shaded by the blue as it goes by. So what we've got here is we've got the answer being this stuff right here. So again, kind of like doing this in black to make sure we're all clear on this. The answer is this stuff in between here. So we're going to fill in here, we're going to fill in here, and then we're going to lightly shade this. So there would be the answer. Okay. So again, notice that this one was written without the word and, without a symbol or anything like that. It's just this little interval right here. This one right here is got the word and, but it turns out to be this little interval right here. And I want to show you one more thing. It is possible to write this using one single inequality. The answers are in between 5 and -3, like that. So the answers are bigger than -3 and they're less than 5. That would be another way to write it. So totally okay to write it this way, totally okay to graph it and all that sort of stuff, but that's the idea there. So really importantly, keep straight your ands and your ors. So I've got a couple of ands here, a couple of compound inequalities with and. Now you'll notice that these guys here have or in them. So let's run through and do these. So let's see, we are going to subtract 4. So this is going to be x is less than or equal, oops, I'm thinking of the answer, 3. So this would be a -4. I always like rewriting the word there, so I'm going to subtract 3. So this is going to be x is greater than -5. So let's see what we've got on this one. Let me double check and make sure. So x is less than or equal to -4, or x is greater than -5. So let's see what happens here. Let's see, so I've got 0 here, I've got -4 here, and I've got -5 here. Let's do the -4 first. So we're going to fill that in, and we want the numbers that are less than that, so we'd shade this way. And we've got x is greater than -5, so we're going to circle that in. It's not filled in, but then we want them bigger, so that's going to be shaded that direction. So this is kind of interesting. On this one, remember, any type of shading is okay. So if we started here and went that way, that would shade everything that direction. If we start here and go this way, that would shade everything that direction. So basically the entire number line is shaded on this one. Okay? So on this one, here's our answer. We just shade from one end to the other, and I'm going to double this one up so it looks like this. Now this is a weird one, and we're going to talk a little bit more about these after we've done a couple more, but it is possible to have that happen, so just kind of keep that in mind. Kind of interesting there. And then you'll notice again, comparing the ands and the ors, this one is an and. It can be written without the word and or the symbol. When you use an or, you've got to use the word or that symbol for the union. All right, let's take a look at the next one. On this one, I've got a little typo here. Let's go ahead and fix that. I believe this should be a minus, so if that hasn't been fixed on your paper, let's make sure that's a minus. First thing we want to do here is we want to multiply both sides by 2. Multiplying by 2 doesn't change the direction of the inequality. Those are going to cancel, so this is going to be 3x minus 5 less than, and this is going to be a 4. We're going to add 5, so we get 3x less than 9. Oh good, this works out well. We don't have to change direction on any inequalities or anything, so this is going to be a 3, so we're in good shape there. And again, the word that connects these is or, so I'm going to go ahead and write that. And then on this one, so here's what I'm going to do on this one. I am going to go ahead and use a different color, and I'm going to use that technique where we clear the fractions. I don't want to work with that 1/3 or the dividing by 9, so here's what we're going to do. We can multiply by a 9. That will cancel off a 3 and a 9. If you want to go through and solve this with the fractions, that's totally okay. Let's see if we can make this work out nicely. So if we multiply by 9, those are going to cancel, so that's going to leave a 3. And we're multiplying by a positive 9, so that's not going to change anything. The 9s will cancel, so that'll leave a -x. And 9 times 3, that's going to be a 27. So we'll finish solving this. We're going to subtract, we'll subtract 27. So we end up with -24. That's a -x. And then we're going to divide both sides by a negative, or just make the opposite of each one of these things. So this is going to be a 24. This is going to be a greater than, and this is going to be an x. So we've got our pieces here, and the word is or, so anything with any type of shading is going to be okay here. So let's take a look here. I'm going to put 0 about right here. I'm going to put 3 about right here. We are going to leave that open, and we're going to shade this direction. Okay, so we'll just do a quick little sketch of this for the time being. And 24 is right here, and the answers are bigger than 24, so we're going to shade that direction. Okay, so it turns out, let's see, they don't overlap or anything. One heads one way, the other heads the other. So anything that's shaded by the red is perfectly good. So I'm going to do a black mark and fill that in, go like this. On this one, we're going to fill this one in, go like that. And again, neither one of them are filled in. So the answers are basically going to start way down here at like -infinity, go all the way up, right up to 3, not including 3. And then they're going to start over again at 24 and go all the way to the end. Okay, now we've seen some interesting problems, and these are a handful. These are going to take a while to get used to, but I do want to run through a quick thought experiment, because some compound inequalities have answers that just look a little strange. They're a little bit surprising when you get done with these. So this is solve, graph, and describe what the range of the answers would be. So this one doesn't need to be solved. This one does, so I'm going to subtract 2. So this is x is less than or equal to -5. And the word here is and. So and means both. We need to see where they overlap. So we're looking for the overlap, or where they cross. So we're looking for the overlap. So I've got 0 here. I've got -1 here. And we're going to fill that in, and we would shade. This would be greater than. Okay, and this is -5. And we'd fill that in, and this is less than, so we shade that way. So we want to know where they overlap. Well, they head in different directions, so there is no overlap. So on this one, there is no solution, okay? So it's possible, just like with the equations, we can have inequalities that don't have solutions either. Okay, let's look at this one. The word here is or. So notice that they're already solved here. So or, any type of shading is going to be okay on this one. I'm going to put 0 here. I'm going to put 2 here, and I'm going to put 5 here, equal to this one. So this is going to be shaded less than 2, so we're going to shade that way. And this one is less than 5, so we're going to shade that way. Any type of shading is okay on this one, so stop and think about this. Well, nothing is shaded up here, but we're shaded here from 5 all the way down here. Kind of double shaded here, but double shading doesn't help us at all. So really the answers would just be from 5 all the way down here. That first one, it turns out, doesn't really matter because as we shade down from 5, it kind of overlaps right on top of that too. So really just one of those would do as far as the answer goes. Let's slide down here and take a look at a couple more. Again, this one's already solved, so we've got 2. So I'm going to, I'll put 0 on here, and that's going to be filled in. And I'm going to put 2 on here, and that's not going to be filled in. We would shade less than 2, so that's going to go that direction. Or greater than or equal to 0, so greater than would be this direction. And the word is or, so we're looking for any type of shading at all. So this is like that example up above where everything was shaded. So the answer on this one is going to be everything. The whole thing from one end to the other. So it's going to look like this. And again, these kind of get messy. That's why sometimes it's nice to kind of sketch out what your answer is and then do the final answer on a number line. So any number here would work. Anything less than 5. So the answers, anything less than 5 would work there. And then let's take a look at this very last one here. So we've got, let's see here, -3. So we're going to circle that and we will fill it in. And less than, so we're going to shade that way. -3 again, and we're going to fill it in, and it says greater than, so we're going to shade this way. And means both. So that means both types of shading. So the only thing that got shaded twice, this all has one type of shading, this all has one type of shading, but the fact that we shaded that in on both of them means that is the only part of the answer. So this is it right here. The only answer on this one would just be the -3. So x equals -3 is the only answer on that one. Now, go ahead and do the self-assessment, see how you feel right now, and then I'm going to take a quick look at a couple of these problems over here. We're going to look at problem number 1. Okay, so on this one, it says write a compound inequality that represents the following graph. Use at least one using the word and. So on this one, here's the answer, and I'm going to help you out on this one. I showed you a quick way to write these down on the notes page. On this one, I am going to use the word and because there are two parts of this. So what we want here is -40. We want answers that are greater than or equal to that, and at the same time, so I'm going to write the word and. We want answers that are less than 60, so over here. So I'm going to do x is less than 60, and you'll notice because that's open, I'm going to leave that not equal to, and because that's closed, I'm going to make that equal to. So this right here would be the inequality that we would use to represent that. All right, good luck with the assignment. If you need to watch this again, if you need some help, these do take a while to sink in, but you can get them no problem. Good luck.